Okay, so here we are, part 2 of the video, just looking for a couple more example problems. I'm going to go over 4 example problems, and they're on page 638. So again, this is not a requirement unless I told you that you have to do it. However, it's just for some extra practice. So let's take a look at number 1. It says h minus 6 is greater than or equal to 13. So we're still going to do the solve and check. So we're going to solve over here and then check right here. So we're going to rewrite this twice. So h minus 6 is less than or equal to 13. H minus 6 is less than, not less than, greater than or equal to 13. I'm not sure if I said that the first time or not, but anyways, doesn't matter. I know what I mean. Okay, so if I'm subtracting 6 from that variable, the inverse operation to get that variable by itself is to add 6. So I'm going to add 6 to both sides, which means, and I'm just going to kind of skedaddle over this way, h is going to be greater than or equal to, and I'm going to do 13 plus 6, which is 19. And I'm going to go ahead and make my number line. So I'm just going to go ahead and put 19 in the middle, 20, 21, 22, and then I'm going to work backwards, 18, 17, 16, and I'm going to go ahead and circle that number 19, okay? Now, is it an open dot or a closed dot? It is a closed dot because it is included in the answer choice. So h is greater than, which means my arrow is going to go this way, okay? So now I'm going to check it. I'm going to replace my h with one of these numbers. So I'm going to go ahead and just pick 20. 20 minus 6, and I'm just arrowing over because I just don't have enough room. 20 minus 6 is greater than or equal to 13. So 20 minus 6 I know is 14. Greater than or equal to 13. Is 14 greater than or equal to 13? Yes, it is. We have done it correctly. All right, let's take a look at this next one. I'm going to kind of move over this way a little bit more since I ran out of room on that last one. All right. Oops. Solve and check. Okay, so 5y is greater than 30. 5y is greater than 30. Okay, so there's my problem. And now what I'm going to do is I'm going to, since I'm looking at isolating the variable, which is my y, I know I'm multiplying, so the inverse operation of multiplying is dividing. Whatever I do to one side, I must do to the other side. So 5 divided by 5 is 1, which means I'm left with 1y, is greater than 30 divided by 5 is 6. Now that I've solved, I'm going to come over here, and I'm going to go 6 in the middle, 7, 8, 9, 5, 4. It doesn't matter as long as you have some numbers. So I'm going to put my circle on my 6. It is an opened dot because it is not included in the solution, and y is greater than 6. So therefore, I have to go over that way. Now I'm going to pick one of these numbers that is on the number line. So I'm going to, that is a solution. I'm not going to pick one over here. That's not a solution. I didn't make my arrow go that direction. So I'm just going to go ahead and pick 8. So 5 times 8 is greater than 30. 5 times 8 is 40. Is 40 greater than 30? Yes, we have done it correctly. Okay, let's take a look at this one. Joanna's parents give her $10 per week for lunch money. She cannot decide whether she wants to buy or pack her lunch. Decisions. If a hot lunch at school costs $2, which is cheap, okay, right? And that's like, the Minsky's pizza costs more than that, doesn't it? I don't know, but I'm pretty sure it's more than $2. Write and solve an inequality to find the maximum number of times per week Joanna can buy her lunch. So she can spend at least $10, right? Yes. So let's pick a variable, and I'm just going to pick B. So lunch costs $2 every single time she goes, so 2B, and we know that that has to be less than or equal to $10. Okay, because every time she buys a lunch, it's going to cost her $2. So 2 Like if she bought one lunch, it's going to cost $2. If she buys, my light just went off again, good gravy. Okay, if she buys 2 lunches, that's going to be, 2 times 2. Okay, so that's going to give me 4. Okay, if she buys 3 lunch, it's going to, 2 times 3 is 6. So if I'm going to be multiplying the number of lunches that I buy by 2, because every time we're got to figure out how many lunches she could buy at most. Okay, I'm going to divide each of these by 2, and I'm left with B. I might have to come over here again. B is less than or equal to, and then I'm going to take 10 divided by 2, which is 5. So the maximum amount of numbers that she could buy without going over her $10 is 5 lunches. So next thing we're going to do, we are going to go ahead and make a number line. Now, does it say to make a number line? No. Are we going to do it? Yes. Heavens, yes. 5, 6, 7, 4, 3. Now, open dot or closed dot. It is going to be a closed dot, okay, because we can't have up to 5 lunches that we could buy. But it is going to be B is less than 5. So my arrow is going to go this way. Here we go. So now let's check it. So coming over here on our check, we're going to go back to 2B is less than or equal to 10. And now I have to pick a number that is on my number line that I'm showing as a possible solution. Let's say she buys 3 lunches. So 2 times 3, because each lunch costs, remember, $2. So 2 times 3 is 6. Is 6 less than or equal to 10? Yes. Therefore, she could buy up to 3 lunches. She could buy up to 4 lunches. She could buy up to 5 lunches. But could she buy 6 lunches at school? No, she can't. And how do we know that? Well, if we go back to this problem, and let's say she buys 6 lunches. 2 times 6 is less than or equal to 10. Well, what's 2 times 6? 12. Is 12 less than or equal to 10? No, it is not. Therefore, that is not a solution. Okay, very good. I think that is good because that was a little bit longer than expected because I did more with that problem. So those are 3 extra problems in case you needed some extra help. If you need more practice, make sure you ask Mrs. Horner, myself, okay, if you are understanding. But I'm sure you've got it. You're good to go. Have an awesome, fantastic day. Get your homework done. Okay, bye.